everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation from z equal to f of x plus ay plus g of x plus by by eliminating the arbitrary function. So here we are given a relation. We are asked to form a partial differential equation by eliminating this arbitrary functions f and g. So let's see. Given z equal to f of x plus ay plus g of x plus by, right? Consider as equation number 1. Now let's partially differentiate it with respect to x. Here we are going to find p, q, r, s, t. Okay, that is we are going to differentiate it with respect to x, that is partially differentiate one with respect to x, with respect to y. Again we'll find the second derivative of z with respect to x and with respect to y, and also with respect to x and y. Let's see how we are going to do this. Okay, I'll begin with p. First we'll find p, that is dou z by dou x. First we'll find just the partial derivative of 1 with respect to x. Okay, partially differentiating 1 with respect to x. It's nothing but just we'll partially differentiate equation 1 with respect to x. This gives us dou z by dou x, which can be replaced by the notation p, right? Fine. Now just you can apply dou by dou x on both sides of the equation. You'll get dou z by dou x equal to, here we are partially differentiating with respect to x, so we'll treat y as constant, okay, and also treat a and b as some constants, right? Fine. Now partial derivative of x plus ay with respect to x is f dash of x plus ay into inner derivative. Partial derivative of x with respect to x is 1 plus partial derivative of ay with respect to x is 0 plus partial derivative of g of x plus by is g dash of x plus by into inner derivative. Partial derivative of x with respect to x is 1 plus partial derivative of by with respect to x is 0, right? And also we have dou z by dou x equal to p. Okay, we'll replace it by p. This gives us p equal to f dash of x plus ay. See, 1 plus 0 is 1. 1 into f dash of x plus ay is f dash of x plus ay, plus 1 plus 0 1. 1 into g dash is g dash, that is g dash of x plus by. Now consider some equation number 2. Okay, if necessary we can replace this b by dou z by dou x. Okay, remember p equal to dou z by dou x. Okay, we have just replaced it by p. There is nothing but dou z by dou x equal to f dash plus g dash. Okay, f dash is nothing but f dash of x plus ay, and g dash is nothing but g dash of x plus by, right? Now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. Just apply dou by dou y on both sides of 1. We'll get dou z by dou y equal to, here we are partially differentiating with respect to y, so we'll treat x as constant. We'll get f dash of x plus ay into inner derivative. Partial derivative of x with respect to y is 0 plus constant a into partial derivative of y with respect to y is 1 plus partial derivative of this term. We'll get g dash of x plus by into inner derivative. Partial derivative of x with respect to x is 0. Sorry, partial derivative of x with respect to y is 0 plus b into partial derivative of y with respect to y is 1, right? And also we have the notation dou z by dou y equal to q. So we'll replace dou z by dou y by q. We'll get q equal to a into 1 a plus 0 a into f dash is a, f dash is nothing but f dash of x plus ay, right? Now b into 1 is b plus 0 is b into this is b into g dash of x plus by. Consider as equation number 3. Now we'll find r. R is nothing but dou square z by dou x square, right? Which is nothing but partial derivative of dou z by dou x with respect to x gives r, right? So what we'll do now is we'll just partially differentiate this equation 2 with respect to x. Okay, that is we are finding second derivative of 1 with respect to x simply. Okay, fine. Here we can write dou z by dou x as p. So partial derivative of p with respect to x gives r. Okay, fine. R is nothing but an equation which contains r. Okay, here we got an equation which has p. Here we got an equation which has q. Okay, don't get confused. Fine. Now we have 1, 2, 3, 3 equations. We got p and q. I mean equation with p and equation with q. Now we'll find equation with r, equation with s, and equation with t. Fine. Now let's partially differentiate equation 2 with respect to x. Partially differentiating 2 with respect to x. Okay, just apply dou by dou x on both sides of the equation. See, it is not necessary to write, but to avoid mistakes, just take dou by dou x on both sides of the equation. Okay, this gives us dou by dou x of, here we can just directly write dou p by dou x, which is r, but I'm going to write this p as dou z by dou x. Okay, in the next step, in the coming steps, we can just write or replace it by r. Okay, now here we are partially differentiating with respect to x, right? So we'll treat y as constant and a and b are also constants here. So we'll get f dash of x plus ay into inner derivative, that is dou by dou x of x plus ay. You can avoid this step and write directly 1 plus 0 or 1, simply 1. And yeah, partial derivative of f dash of x plus ay is f double dash of x plus ay into inner derivative, that is partial derivative of x plus ay with respect to x, plus partial derivative of g dash of x plus by with respect to x is g double dash of x plus by into inner derivative, that is dou by dou x of x plus by, right? If you are really good at derivatives, please do directly. I'm just doing this to help both students, okay, who are really that okay at partial derivatives. Fine. You can write this as dou square z by dou x square equal to f double dash of x plus ay into partial derivative of x with respect to x is 1 plus partial derivative of ay with respect to x is 0, since ay is treated as constant here, right? A is constant and y is treated as constant since we are doing partial derivatives, right? Fine. Plus g double dash of x plus by into partial derivative of x with respect to x is 1 plus partial derivative of by with respect to x is 0. Since we have a notation dou square z by dou x square equal to r, we'll just replace this by r. We'll get r equal to 1 plus 0, 1. 1 into f double dash is f double dash, that is f double dash of x plus ay. Here also 1 plus 0 is 1. 1 into g double dash is g double dash, that is plus g double dash of x plus by. Consider as equation number say 4. Right? We got r. Now let's find t. Okay, I'll find s finally for my convenience. Okay, Sometimes we'll get the partial differential equation with the help of P, Q, R and T. Okay, if it's necessary, then only we'll find S in many cases. So what we'll do is we'll just find all these three and the last one first, and then if it is necessary, we'll go for S also. Okay, fine. Now let's partially differentiate 3 with respect to what? With respect to y to find t. Since t equal to dou square z by dou y square, right? You can write this as dou by dou y of dou z by dou y. We know that dou z by dou y is q, right? We have a notation. We have used it many times. So by finding partial derivative of q with respect to y, we'll get t. Okay? I'm calling equation 3 as equation q simply because this is the only equation which has q here, right? So I'm calling it as equation 2. Actually, why we are just solving is to recognize that by finding partial derivative of equation 3, we can get the equation which involves t. Okay? Fine, now let's find equation that involves t. Right. Now let's partially differentiate equation 3 with respect to y. Partially differentiating equation 3 with respect to y. Just apply dou by dou y on both sides of 3. Here we are partially differentiating with respect to y, so we'll treat x as constant. A into f dash of x plus ay plus b into g dash of x plus by. Right? This gives us dou by dou y of, here itself you can write t because dou q by dou y gives t. Okay? But I'll just replace q by dou z by dou y for my convenience. Okay? It looks good. Finally, you can write the equation with t equal to something. Right? A is constant, write a into partial derivative of f dash of x plus ay is f double dash of x plus ay into inner derivative, that is dou by dou y of x plus ay plus constant b into partial derivative of g dash of x plus by with respect to y is g double dash of x plus by into inner derivative, that is dou by dou y of x plus by. This gives us dou square z by dou y square equal to a into f double dash of x plus ay into partial derivative of x with respect to y is 0 plus constant a into partial derivative of y with respect to y is 1 plus b into g double dash of x plus by into partial derivative of x with respect to y is 0 plus b into partial derivative of y with respect to y is 1. Right? Since we have a notation dou square z by dou y square equal to t, just replace it by t since t equal to dou square z by dou y square. Right? We'll just replace it by t equal to a into 1 a plus 0 a into a square, f double dash of x plus ay plus b into 1 b plus 0 b into b square into g double dash of x plus by, considered as equation number 5. Now we got the 4 equations p, q, r, t. 4 equations involving p, q, r and t. Okay? Now observe all these four equations. Here we have f dash g dash, af dash, bg dash, f double dash, g double dash, a square f double dash, b square, g double dash. And there is no possibility of finding PD using these equations. Now it's necessary to find S also. Why I'm saying it's not, it's impossible to find equation with this 4 or 5 equations is, here we have constant a square and here we have constant b square, right? We can't take any of these constants common from these two equations. You can't take anything common from these two equations, these two terms simply, or you can't take anything common from these two or from these two, right? There is no possibility to find partial differential equation. You just need to observe all these equations. Then only you'll get to know that here we have a square and here we have b square. Here we have a and here we have b. We don't have such terms we can take common, right? So what we'll do is simply we'll find S and let's see what happens. So how you can find S? We have two ways to find S. What is S? S is nothing but dou square z by dou x dou y. We can write this as dou by dou x of dou z by dou y or dou by dou y of dou z by dou x. Okay, we have two ways to find S, either this or this. Fine. Now this is equal to dou by dou x of, we know that dou z by dou y is nothing but q. So partially differentiating the equation that involves q with respect to x gives equation S. Likewise here, if you consider it, you'll get dou by dou y of, we know that dou z by dou x is p, right? So partial derivative of equation that involves p with respect to y gives S. You can either try this or try this. Let's see both. Okay, I'll show you in both the cases. Fine. Now, yeah, we need to find S, right? So let's try the first one, dou q by dou x, that is partially differentiating 3 with respect to x. Partially, this is R, okay? Partially differentiating 3 with respect to x. We'll get dou by dou x of q equal to dou by dou x. So just apply dou by dou x on both sides of equation 3, okay? A into f dash of x plus ay plus b into g dash of x plus by, right? This gives us, I'll just write directly S, okay? Or you can just write dou z by dou y. So constant a into partial derivative of f dash of x plus ay is f double dash of x plus ay into partial derivative, here you have to find inner derivative also, right? Partial derivative of x plus ay. Partial derivative of x with respect to x is 1 plus partial derivative of ay with respect to x is 0 plus b into partial derivative of g dash is g double dash into inner derivative, partial derivative of x with respect to x is 1 plus partial derivative of by with respect to x is 0. Okay, already I have shown how to find partial derivative while finding equation 4 and equation 5. Okay, you can check there. Now this gives us dou square z by dou x dou y, which is equal to 1 into 0 1 1 into a into f dash f double dash of x plus ay plus 1 into 0 1 1 into b into g double dash of x plus by, right? We know that this S, since dou square z by dou x dou y equal to S, right? This gives us S equal to a into f double dash of x plus ay plus b into g double dash of x plus by. Consider as equation number say 6. Right. Now let's see the other way how to find with the help of dou p by dou y. Just partially differentiate equation 2 with respect to y. Partially differentiating 2 with respect to y. We'll get dou by dou y of p equal to dou by dou y of f dash of x plus ay plus g dash of x plus by. We'll have, since p equal to dou z by dou x, right? Just replace it. We'll get, here we are partially differentiating with respect to y, so we'll treat x as constant. Here x are treated as constant, and partial derivative of f dash of x plus ay is f double dash of x plus ay into inner derivative, that is dou by dou y of x plus ay. This is the correct procedure to find partial derivative of this term. Okay, here we just skipped it. Plus partial derivative of g dash of x plus by with respect to y is g double dash of x plus by into inner derivative, that is dou by dou y of x plus by. Clear, right? This gives us dou square z by dou x dou y equal to f double dash of x plus ay into partial derivative of x with respect to y is 0 plus a into partial derivative of y with respect to y is 1 plus g double dash of x plus by into partial derivative of x with respect to y is 0 plus constant b into partial derivative of y with respect to y is 1. Right? This gives us, since we have dou square z by dou x dou y equal to s, we can just replace it by the notation s. We'll get s equal to a into 1 a plus 0 a. You'll get a into f double dash, that is f double dash of x plus ay plus b into 1 b plus 0 b. So you'll get b into g double dash, b into g double dash of x plus by. See, you got the same equation. By partially differentiating equation 3 with respect to x, you will get the equation involving s. The same equation you will get by partially differentiating this 2 with respect to y. Okay, you can pick any of these two. Fine. Finally, we got an equation with respect to x, right? Now observe the equations and see how to find or form a partial differential equation. Okay, I'm going to observe R, T, S. Okay, because only these three equations involves f double dash and g double dash, right? Fine. Now we have R is equal to f double dash of x plus ay plus g double dash of x plus by, right? And equation involving T, a square f double dash of x plus ay plus b square g double dash of x plus by, and S, a into f double dash of x plus ay plus b into g double dash of x plus by. There is some similarity here. Here we have as a square, a, and we don't have any constants, b square and b, right? So now focus on a square and a and f double dash. Okay, so to eliminate f double dash from any of the two equations, what you can do is you can just try ar minus s. Okay, if you try ar minus s, the term involving a f double dash of x plus ay gets eliminated, right? Or focus on a square and f double dash. If you want to focus on a square f double dash, you need a here. So you need to try, you may need to try as minus t, so that you'll get a into a square f double dash of x plus ay minus a square f double dash of x plus ay gets cancelled, right? So the term involving f double dash gets cancelled using ar minus s and as minus t. So let's go for it. First we'll try the first one, ar minus s. What is ar? I'll write ar minus s. Ar is nothing but a times r, that is a into f double dash of x plus ay plus a into g double dash of x plus by minus s. Minus s is nothing but a f double dash of x plus ay, or write one more step, nothing is wrong in it. Okay, or you can just, okay, a r minus s simply, right? This gives us a into f double dash of x plus ay plus a into g double dash of x plus by minus a into f double dash of x plus ay minus a into what a? Here we have b, right? You need to write b. b g double dash of x plus by, right? So here plus a double dash and minus, a f double dash and minus a f double dash gets cancelled, right? And this gives us ar minus s equal to a into g double dash of x plus by minus b into g double dash of x plus by, right? Okay, so you can take g double dash common from these two terms because we have a into g double dash minus b into g double dash, right? You can just take g double dash common from these two. We'll write this as ar minus s equal to a minus b into g double dash of x plus by, right? Consider it as some equation number 7, say. Now let's go for this as minus t. s is nothing but a into f double dash of x plus ay plus b into g double dash of x plus by minus t, a square f double dash of x plus ay plus b square g double dash of x plus by, right? Fine. This gives us a square f double dash of x plus ay plus ab g double dash of x plus by minus a square f double dash of x plus ay minus into plus minus b square g double dash of x plus by. Here a square f double dash minus a square f double dash gets cancelled. This is what we have planned, right? Already we have tried, using trial and error method, right? We just focused on eliminating f double dash, right? So f double dash got eliminated. Here also we have eliminated f double dash, and here also we are eliminating f double dash, right? And this results to a b g double dash of x plus by minus b square g double dash of x plus by, right? And here you can take b and g double dash common from these two terms, right? Since we have b in both the terms. So let's take b double dash, b into g double dash common from these two terms. Okay, we'll get a minus b. You'll get, see, a b g double dash, just the first term, minus b into b square g double dash, right? So you got as minus t equal to a minus b times b into g double dash. Consider as equation number 8. Now observe 7 and 8. Here you are having g double dash and here also you are having g double dash, right? Using 7 by 8, this g double dash gets eliminated and finally we'll get the required partial differential equation. Okay, let's see. Fine, now 7 by 8 gives LHS of 7, LHS of 8, RHS of 7, RHS of 8. Right? Where g double dash gets cancelled and a minus b gets cancelled, and this results to ar minus s by as minus t equal to 1 by b. Right? Now make a cross multiplication to simplify it. You'll get b times ar minus s equal to 1 into as minus t, which gives us abr minus bs equal to as minus t. Right? This term involves s and this term also involves s. Let's bring this or take this to RHS and let's bring this to LHS. You'll get abr plus t equal to as plus bs, right? This minus bs becomes plus bs if you take this if we take this to RHS. Fine, now we'll get abr plus t equal to a plus b times s. Just take s common from these two terms. So this is a required partial differential equation. Bit lengthy, right? Therefore, abr plus t equal to a plus b into s is the required partial differential equation. See, in order to solve these kind of problems, you need to observe the equations z, p, q, r, s, t. Again, I'm telling you, p is nothing but the equation that involves p. See, you don't have any other equation that is involving p here, right? Only one equation involves p, only one equation involves q, only one equation involves r, and only one equation involves t, likewise s, right? So don't get confused. P is nothing but equation that involves p in my words, okay? Fine. So this completes the problem. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.